Hello 10th class students. So we are about to finish the current academic year as per the government guidelines. We are into the last chapter, current electricity. This chapter is very important for you in future, as well as in any competitive exam what you will be writing in the further studies. So do watch this particular video which I am giving you. These are the list of videos, and these videos are of very big length. Okay, so watch them again and again till you understand each and every concept clearly. I repeat, watch these videos again and again till you understand the concepts clearly.
Let's look at this situation which we'd seen in one of our earlier videos. Two beakers are connected by a pipe, and one of the beakers is placed at a height above the other, and the water will flow from this beaker to this one. Now listen to me carefully. If you understand this simple situation well, you will understand Ohm's law too. Just focus for the next 2 minutes and you will master Ohm's law. As we discussed, it's the height difference that makes the water flow from the beaker on top to the one at the bottom. What happens if I increase the height difference? The flow of water will be faster, correct? Absolutely. So we can say that the flow of water is directly proportional to the height difference. Now let's look at another factor. How thin the pipe is. What will happen if I make the pipe thinner? The flow of water will be slower, right? That's correct. Thinner the pipe, slower the flow. So we can say that the flow is inversely proportional to thinness. Looking at these two relations, we can say that the flow is equal to h over t. The flow is directly proportional to the height difference and inversely proportional to the thinness. Why did I give you this example? Because it's analogous to the Ohm's law. The flow of water is analogous to the flow of current. The height difference is analogous to the voltage or potential difference. And the thinness is analogous to the resistance. The flow of current is directly proportional to the potential difference between the points and inversely proportional to the resistance. If the potential difference between 2 points is more, the current flowing through it will be more. And if the resistance is more, the current flowing through it will be lesser. This is assuming that the other factors are constant. This is the basic concept of Ohm's law, and there are many different ways in which we can understand it. We will dive a bit deeper into this concept in the coming videos. What do you understand by the word conduct? Well, in physics, it means transfer of something. And the materials that transfer something through themselves from one place to another are called conductors. That something could be anything. It could be heat, it could be electricity, or many other things. However, here we are interested in electricity. In this context, we will use the word electrical conductors. So now can we define it? You're right. Electrical conductors are the materials that transfer electricity through them. Or even more precisely, they are the materials that allow the electric current to flow through them. For simplicity, we will call them conductors. What are the examples of conductors? We have seen this simple circuit in the previous video. Here, a 1.5 volt cell is connected with a bulb which can be between 3 to 4 volts with the help of copper wires. So here I told you that the movement of electrons is from the negative terminal of the cell to the positive terminal. But however, by convention, the direction of electric current is taken to be from the positive to the negative one. But how exactly is the current flowing in the circuit? Or through which material is this current flowing? Yes, it's the copper wires. Electric current is flowing through the copper wires from the positive to the negative terminal. So what can we conclude from this? We say that the copper is a conductor of electricity since it allows the electricity to flow through it. Now, instead of copper wires, what if we use pieces of threads in the circuit? Will the bulb glow in that case? No, it won't. Why? Because the electric current cannot flow through a piece of thread. Such materials are called insulators. So how do we define this term? Give it a try. These are the materials which do not allow the electric current to flow through them. Let's study a bit about conductors first. Besides copper, what are the other materials that conduct electricity? Almost all metals conduct electricity. Silver, gold, aluminium, iron and mercury are a few other examples of metals that conduct electric current. If you replace copper wires in our circuit with aluminium ones, then you will find that the bulb is still glowing. This proves that aluminium allows electric current to flow through it. In fact, this area of the bulb is itself made up of metal. Hence, if we connect the wire anywhere in this region, the bulb will still glow. It transfers the electricity to the terminal of the bulb and inside. We can actually test any object for conductivity. Break the circuit up from anywhere by cutting the copper wire. Now at this point, I want you to notice one thing. Look at this region. There is nothing present in this region that can transfer the electrical energy from one side to the other. But there is air in this region. So what can you infer from this? This tells us that air is an insulator. It does not conduct electricity. Bring any object that you want to test, say this iron nail. Tie up both the ends of the wires at the two ends of iron and see if the bulb is glowing or not. If it glows, then it proves that the material that our object is made up of conducts electricity. Here the electric current is flowing through the iron nail. So our circuit is complete and the bulb glows. So this proves that iron is a conductor of electricity. Did you know that the human body is also a conductor of electricity? In fact, it's a very good conductor. This is the reason why we get an electric shock if we are not careful. The electric current flows through a body towards the earth. Now, which are the materials that do not conduct electricity? Materials such as plastic, rubber, cotton and wood do not conduct electricity. So they are insulators. For instance, instead of an iron nail, if we connect a plastic straw between the circuit, then the bulb will not glow. Do you remember what resistance is in an electric circuit? It is something that controls the flow of current. If it's more, then the current reading will be lower, and if it's less, then the current reading will be higher. It's inversely proportional to the current. Let's talk a bit more about resistance. What are the factors on which a resistance of a conductor depends? When can we say that the resistance of a conductor is more or less than that of another? Let's do a small activity to understand this. Take a small electric circuit like this one, which has a plug key, a power source and an ammeter. In the first case, connect a nichrome wire between these 2 points. Let the length of this nichrome wire be a lowercase l. Now plug the key and measure the reading in the ammeter. Now let's try playing with the factors a bit. In the second case, we double the length of the nichrome wire, but keep the thickness same. We just double the length. When you measure the reading, you will notice that the current is half of the current measured originally. When the length was doubled, the current halved. In the third case, we replace the wire with a thicker nichrome wire with length L. Understand this case well. We're just increasing the thickness of the wire without changing the original length L. Now, if you're increasing the thickness of the wire, it simply means we're increasing cross-sectional area. Let's call it A. Now, when you measure the current, you will notice that it's more than the original current I1. The results we're getting are pretty interesting. Let's try out one last case. We use a copper wire instead of a nichrome wire. The length and cross-section area A will be the same as the original wire, but the material has changed entirely. When you measure the current, you will notice that it's more than I1. Now let's understand the results case by case. We see that as the length of the wire increases, the current reduces by the same factor. It implies that the current is inversely proportional to the length of the wire. And by Ohm's law, we know that the current is inversely proportional to the resistance of the conductor. So these two together will imply that the resistance R is directly proportional to the length of the wire. More the length of the wire, more will be the resistance. Note that here we assume everything else will be constant. It'll be the same wire and it'll have the same cross-sectional area, and other factors like temperature will also be constant. So the length of the wire is one of the factors on which the resistance of a conductor depends. The resistance of a conductor is directly proportional to the length of that conductor. The third case tells us that as the thickness of the wire was increased, the current flowing through it also increased. It tells us that the current flowing through a conductor is directly proportional to the cross-sectional area of that conductor, which means that the resistance will be inversely proportional to the cross-sectional area of the conductor. Combining these two tells us that the resistance is directly proportional to the length of the conductor and inversely proportional to its cross-sectional area. If we introduce a constant ρ, it can be written like this. This is the constant of proportionality and is called the electric resistivity of the material of the conductor. In the fourth case, we saw that as the nature of the material changes, the current flowing through the conductor also changes. And that's because as the nature of the material changes, its electric resistivity also changes accordingly. Conductors, for instance, have lesser resistivity as compared to alloys, and alloys have lesser resistivity as compared to insulators. Nichrome is an alloy, while copper is a metal which is a good conductor of electricity. And that's why the current reading increased when the material changed to copper. The SI unit of resistivity is ohm meter. How is it ohm meter? We can look at this formula and deduce it. The unit of resistance is ohm, the unit of length is meters, and that of area is meter squared. Cancelling and transposing the units gives us the SI unit of ρ as ohm meter. We will understand resistivity in detail in the next video. But before we end this video, let's quickly review what we learned. The resistance of a conductor is directly proportional to its length and inversely proportional to its cross-sectional area. And it also depends on the nature of the material. If the material has low resistivity, its resistance will be lower, and if it has more resistivity, its resistance will be higher.
Particles with opposite charges attract one another. We can view this by saying that the positive particles that are far away from the negative particle have a higher potential energy, just as in the case of gravitational potential energy. Particles with the same charge repel one another. We again can view this as a case of potential energy. Although gravitational fields affect all objects in the same way, electric fields have an opposite effect on positive particles than they do on negative particles. From a negative particle's point of view, the potential energy throughout space is flipped upside down, as compared to a positive particle's point of view. Every charged particle contributes to shaping the electric potential energy at each point in space. The effect of each particle adds together. Suppose we have charged particles that are trapped inside a container. The charged particles will move to the edges of the container, causing the electric potential energy to be the same everywhere inside the container. If a container with charged particles experiences an external electric field, the charged particles inside the container will react by again moving in such a way so as to cause the electric potential energy to be the same everywhere inside the container. The charged particles inside the container will react by again moving in such a way so as to cause the electric potential energy to be the same everywhere inside the container. In a metal conductor, the positively charged particles are always fixed at one spot and unable to move. But the negatively charged particles are free to wander around. When the metal conductor experiences an external electric field, one side of the metal will end up having more negative particles than positive particles and develop a net negative charge. The other side of the metal will end up having more positive particles than negative particles and develop a net positive charge. Therefore, the effect is the same as in the example of charged particles inside a container. The electric potential energy is the same everywhere in the metal. In an electric circuit, the negatively charged particles flow through metal wires. Metal wires that are directly connected to each other with metal connections are all at the same electric potential. The difference between the electric potential energy of 2 points of a circuit is what we call the voltage. When a switch closes, it causes the two different parts of a circuit that it connects to be at the same potential energy. The number of charged particles that pass by each second is what we refer to as the current. When electricity was first discovered, it was not known that it is the negatively charged particles that move through wires, and it was incorrectly assumed that it's the positive particles that are moving in the opposite direction. The convention for how we describe the electric current's direction was never updated, and we therefore still refer to this situation as if it is the positive particles that are flowing in the opposite direction. Much more detailed information about voltage, current, and electric circuits is available in the other videos on this channel.
Hello friends, this video on electricity part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are electric current in conductors, electric potential and potential difference, Ohm's law, resistance and resistivity, electric circuits, combination of resistors, heating effects of current, and electric power. So what is the purpose of studying electricity? As we all know, electricity is an extremely useful thing in each of our day-to-day life. So whenever we think of electricity, we think of all these electrical appliances which we use at our home. For example, you switch it on and your bulb glows. You switch it off, it gets switched off. Electric shock, if you touch an open socket, you are attacked by electric shock. Not only that, when you think of electricity, you also remember batteries, which are extremely useful in so many appliances like cameras or cell phones. Your computers, they also need electricity. The electric fans, the transistors or the tape recorders, mobile phones, refrigerators and whatnot. There are so many electrical appliances on which we are dependent for our day-to-day life. So you understand the importance of electricity, right? Even if we have a power cut at our home for an hour or so, it becomes so difficult to live without light, to live without fans and all that stuff. So electricity being so useful, we are going to study the basics of electricity in this lesson. So to start with, we will talk about what is electric current. So that is from where this lesson on electricity starts. So what is electric current? Electric current is nothing but flow of electric charge. So whenever we talk of current, it means it is nothing but flow of charge. So flow of electric charge constitutes electric current. It is measured as rate of flow of charge. That means rate at which the charges are flowing. So we denote electric current often with I, and it is written as dq by dt. That means the rate at which how many charges are flowing per unit time. It is denoted by capital I. SI unit of electric current is ampere, which is abbreviated by a capital A. So whenever we talk of electric current, it is something like, let us suppose if you have a circuit which consists of a bulb, you have a battery and there is a switch. The switch is right now in open mode. Now once you close the switch, the bulb glows. Why does the bulb glow? Because as soon as you close the switch, electric current flows through the circuit. And due to the flow of this electric current, the bulb glows. Right? Now there is something called direction of current. So what is the direction in which the electric current flows? Now as far as direction is concerned, we will talk about two types of current. One is electronic current and the other one is conventional current. Now when we talk about electric current, we talk about flow of electric charge. So basically we are talking about the flow of electrons. right? Flow of electrons is what is called electric current. Now the direction of electronic current, that is the flow of electrons, will take place if this is the positive terminal of the battery and if this is the negative terminal of the battery. The electrons will come out from this terminal, right, from the negative terminal. So the direction of electronic current is from negative to positive. But the direction of conventional current is considered opposite to the direction of electronic current, that is from positive to negative. Now conventional current is what we use everywhere. So wherever we say that current is flowing in the circuit, we mean that conventional current is flowing from positive terminal of the battery towards the negative terminal of the battery. That is what is the direction of conventional current. So what is current? It is nothing but flow of electric charge, or we can say flow of electrons. It is measured as the rate of flow of charge. It is denoted by capital I. SI unit is amperes, and the direction of conventional current is from positive terminal towards the negative terminal. Now how do I define 1 ampere? So how do I define 1 ampere of current? As I mentioned, from the definition of current, we define it as the rate of flow of electric charge. So how do I define 1 ampere? Current will be 1 ampere when 1 coulomb of charge flows in 1 second. Right? So current is 1 ampere is defined as the current when a number of electrons having 1 coulomb of charge move past a given point in 1 second. That means, let us suppose I am considering this point A into consideration. When some n number of electrons having charge 1 coulomb will pass in 1 second, then we define that current as 1 ampere. So 1 ampere is the current when a number of electrons having 1 coulomb of charge move past a point in 1 second. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again. Hello friends, this video on electricity part 2 is brought to you by examfear.com. No more fear from exam. Now the question is, what causes the charge flow? What causes these electric charges to flow? There has to be something which initiates this flow of charges. Look at this example. Let us suppose there is a ball which is kept at the top of this slope, right? Do you see that the ball moves? No, the ball doesn't move. Now let us suppose if you apply a small force to this ball, what happens? The ball starts moving and then it starts rolling on itself along the slope. Why does this happen? Now, when the ball was rolling along this slope, was there somebody who was doing some external work from behind? No. So you applied this trigger. So this force which was applied here was the trigger to start this movement of the ball. So similarly, there is a trigger which initiates the charge flow and then the charge keeps on flowing. Similarly, let us suppose if you have a hot cup of coffee placed on a table. What happens? If you keep the coffee as it is for some time, what happens? The coffee becomes colder. Why does that happen? That's because since the temperature of the coffee is very high as compared to the temperature of the surroundings, heat energy starts flowing from a region of higher temperature towards a region of lower temperature. So gradually heat energy starts flowing from the coffee towards the surroundings. So the coffee keeps on losing heat and as a result, the temperature of the coffee reduces. So what was the trigger in this case? In this case, the trigger was the change in temperature. Since there was a difference in temperature between the coffee and the surroundings, so there was a flow of energy. Similarly, in case of a copper wire, for example, why does this piece of copper wire conduct current? I mean, why does the charges flow within this copper wire? Or when will the charge flow inside this copper wire? Charges flows due to a difference in potential between the two ends. If there is a difference in potential between these two ends of the wire, difference in potential or difference in electric pressure between the two ends of the wire, then the charges will flow from region of higher potential towards the region of lower potential. So if we say that this end is at a greater potential as compared to this end, then there will be flow of charges from this end to this end, and this flow of charges constitute current. Right? So if we say that this end is negative as compared to this end, that means this end has more electrons as compared to this end. So due to the difference in number of electrons, electrons will start moving from this end to the other end. So these flow of charges constitute electric current. So difference in potential between the two ends of a conductor gives rise to the flow of charges, and this flow of charges constitute electric current. Now, how is this potential difference produced? How will you produce this difference in potential between the two ends? Now, potential difference can be produced by a battery or by a combination of one or more cells. In fact, that is the purpose of a battery. If in your chemistry lessons you would have studied the working of a cell. How does a cell works? So what is the purpose of a cell? The internal structure of the cell is such that chemical energy gets converted into electrical energy inside the cell. Therefore, this cell or a combination of cells, which is also known as battery, they are used to provide electrical energy, or they are used to produce potential difference between its two ends so that charge flow can be initiated. You would have seen, if you would have observed any battery carefully, you would see that any battery would have a plus end and a minus end. This shows that one end is positive with respect to the other end. So this shows that there is a difference in potential between the two ends, which will initiate a charge flow when this battery is connected to a circuit. Right? So you understand what causes the charge flow? Difference in potential between the two ends of a conductor initiates charge flow. Let us now introduce electric potential and potential difference. What do I mean by electric potential difference and electric potential? Now, when I talk about electric potential difference, it is nothing but the work required to be done by an external force in moving a charge from one point to another. Let us suppose you have a charge, any charge particle of charge Q. So if you want to take this charge particle from this point A to this point B, some work needs to be done. So the work that needs to be done to move a charge from one point to another point is known as electric potential difference. Because a charge particle will move from one point to another point only when there is a gradient. So this is basically known as electric potential difference. And what is electric potential? Electric potential is nothing but the work done per unit charge in bringing the charge from infinity to that point against electrostatic force. That means, let us suppose I have some charge particle, right? In bringing this charge particle from infinity to a specific point A, whatever is the work done, that is called potential. So what will be the potential of A? Potential of A is the work done in bringing this charge particle from infinity to A. Similarly, what would be the potential at this point B? It would be the work done in bringing this particle from infinity to point B. So that would be the potential at point B. Now what would be the potential difference? The potential difference between A and B will be nothing but the difference of VA and VB. So the difference in potentials, that is the work done in taking the object from point A to point B, becomes the potential difference. So you understand what is potential at A? Work done is in bringing the charge from infinity to A. What is the potential at B? Work done in bringing the charge from infinity to B. What is potential difference between A and B? It is the work done in bringing the charge particle from A to B. So that becomes VA minus VB. Okay. Because this entire thing, infinity to VB, infinity to B is VB, infinity to A is VA, and so VB minus VA is the work done in taking the particle from A to B. Simple, right? So this is how we define electric potential difference and electric potential. So how do we measure potential difference? Potential difference is generally measured by an instrument called voltmeter. So how do we connect a voltmeter in order to measure potential difference? It is connected in parallel across the points between which the potential difference is to be measured. Let us suppose I want to measure the potential difference between these 2 points. So I connect a voltmeter across these 2 points. So the reading of this voltmeter will tell me the potential difference between these 2 points. SI unit of potential difference is volt. Potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other point. This is how we define 1 volt. What is 1 volt? Because as per the definition in the previous slide, we can say that potential is nothing but work done per unit charge. Right? So this is how we define potential. So how do I define 1 volt? 1 volt is nothing but when 1 joule of work is done in moving a charge of 1 coulomb from one point to another. Then we say that the potential difference is 1 volt.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 3 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 2 before going ahead with part 3. Now the question is current a scalar quantity or a vector quantity? Now what is a scalar quantity? A quantity which has only magnitude with itself. When we talk of a vector quantity, it means it has magnitude as well as direction associated with it. So when we talk about current, sometimes people think that current should be a vector quantity because we talk about the direction of conventional current. But if you look at it properly, you will see that current is a scalar quantity. Why? Let us look at this example of distance and displacement. You remembered we spoke about the difference between distance and displacement. When we talk about distance, we say that if this boy moves from his home to this tree and then goes to the church, and then what happens? What is the total distance covered? The total distance covered is this plus this. Correct? So this is the total distance covered. Similarly, in case of current, if I say that there is one resistor like this and there is another resistor like this, so what would be the total current that is flowing through this? The total current comes by adding current flowing through this plus current flowing through this. We never do a vector addition. I mean, we never say that the current flowing from this point to this point we can.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.